Okay, it says inlet port shutoff motor. Inlet port shutoff motor M55. There's M55. Is that right there? So our light went out when I unplugged that. Does that indicate the intake thing is shorted to ground, or is it just provided with a ground? Let me plug it back in. It came back on when I plugged it in, so let me unplug it, plug it back in. So that being an electric motor, is it just on all the time? I assume that means it's shorted internally and providing a ground to that power wire. I think that's fairly conclusive that that device is blowing the fuse. If it was, it shouldn't be on right now. It is a motor that can turn on, and so it can turn on and draw some amperage through it, which would light that, but it's not a motor that rotates. Since it's a variable intake motor, it's going to turn to one position and allow the air to go through one path in the intake and then turn back to the other position. So it should never be on 100% of the time right now like it is. So it almost has to be shorted internally. I don't know enough about these to really say that for sure. I'm going to try and find some information on that device and see if I can read up on it and see what it does. Okay, so I found and printed this information on the intake port function. And it basically says in the charge manifold there's 2 inlet ports available for each cylinder. Each inlet port can be closed by a flap. The flaps are connected to each other with a linkage. They are held open by spring force. And the position of the flaps can be selected by the CDI module, the engine computer. And all these things affect whether or not the computer commands it to work. I'll focus in on that and you can read all of it if you hit pause. But the important part is in the lower engine speed and load range, half the inlet ports are closed by the flaps and the flow rate is thus increased. Okay, so if half of them are closed, the same amount of air is going to go through because RPM determines how much airflow goes through. And if half of them are closed, the same amount of airflow is still going to go through, so the speed is increased through the remaining ports. This leads to a higher swirl, resulting in stronger swirl brings about a more efficient priming of the fuel with the air. In other words, more efficient mixing of the air, and therefore more efficient combustion, resulting in the amount of particulate, resulting in a reduction of the amount of particulate matter in the exhaust gas. So that's why it's got the swirl flaps. And I really think that that device is shorted, causing us to blow that fuse. Okay, at this point I can't get a hold of the customer. We're going to unplug this, plug everything back in, and kind of temporarily sit the, what do we call that, snorkel back in, plug in the mass airflow sensor, and see how well it runs, see what codes reoccur. I would assume just this code is going to reoccur, and we'll obviously have to put a good fuse in there, and we'll video a little bit more when we do that. Okay, we're going to go ahead and clear these codes. Can you turn the ignition off? Okay, we waited 10 seconds. And go ahead and start it and we'll see if those codes reoccur. sure why these are still here, but obviously the big long list of codes is gone. If those codes continue, we might look into them further, but I'm pretty sure the fuse didn't blow. Obviously the fuse isn't blowing, so it might have another problem that's causing this mass airflow sensor code and this exhaust back pressure code. And we do have the customer's okay to fix this now, and we will be pulling it apart. We are going to try and remove that part without pulling the turbo, but based on the instructions in the service manual, it says to pull the turbo, so we will let you know. Okay, Cortland was able to get the intake port shut-off motor out. And there are some plastic clips that are inside here that break. We have received the new intake port shut-off motor. There's the part number in case you want it. And it does not come with those clips. What we're probably going to do is just plug this in and see if it blows the fuse. But it had these little plastic clips and they broke when it come apart. You can probably expect they're going to break every time. Here's the part number of the plastic clips, and you should probably just order these when you get the actuator. And he was able to get this actuator out without pulling the turbo, but there's a strong chance he's not going to be able to get it in because he's going to have to seat it inside those clips and then mount it without pulling the turbo. Not very likely. He's probably going to have to pull the turbo based on what he's saying. You can see the new clips are installed here and here on the they just pop onto little balls there, and we're going to be really careful not to break them. And and we're going to pull the turbo if we have to pull the turbo. So can you plug that in for me? And then we're going to turn the car on and see if it blows this fuse. As we do this test, we're going to clamp off these fuel hoses because it just runs fuel out when you turn the key on. But I'll watch this fuse here while Cortland turns it on. Turn it off. Turn it on. Leave it on. And with this actuator plugged in, it does not blow the fuse. And just as a confirmation, okay, I'm going to plug this in, but I'm going to have the camera focused on this fuse here. Now remember, this is the old one that we think is defective, blowing the fuse. And that's confirmation enough for me. We'll have Cortland put this together, and we will video a little bit if we have to pull this turbo out. So you're going to be able to get that out without pulling the turbo?
It doesn't appear so. The way these clips are designed, they've got to be pushed from underneath into that actuator, and with the turbo in the way, I can't really get my hand or tool underneath there to push those clips in. So it looks like I'm going to have to pull the turbo.
And you've done one of these before?
Yes.
Can you go over what the job entails, and you say you drop the gasket and stuff like that?
There's a bunch of brackets here that's got to be removed. This pipe has to be removed, which we've already done. And you have to work from underneath and up top, and there's a gasket underneath this turbo that, if I remember correctly, you got to be careful to not drop, which I did last time. This strut tower brace has to come out. This cover here, this piece actually removes out. There's some bolts through back there. This will have to come out to get room to see what's going on back there. So, pretty big job, but I've done one before, so.
I wish you luck with it. Okay, Cortland has the turbo out. You can see there's a couple pipes there for it to go on, and he is got the new part installed, and it's going back together. Good job.
Thanks.
Okay, Cortland has finished up the installation of the new intake port shutoff motor. Parts supplier called it an intake manifold actuator. We've already test drove it, and the codes did not reoccur that were related to the fuse blowing. Go ahead and start it, Cortland. But it's running good now. Okay, shut it off. This was an interesting diagnosis for me, and it brings to light that there is a time when shorted wire doesn't cause a fuse to blow. It's a component itself, and unplugging that component is a good test. It also is a good test to use a test light on the load side of the fuse with the clamp hooked to the power, and that'll show you whether the component is still shorted to ground. If you learned anything from this video, be sure and click the like button. If it helped you fix your car and you want to donate to the continued production of these videos, find the donate icon on my website at www.kansascitytdi.com. If you want to watch some more of my videos, there'll be one right there and one right there. And don't forget to subscribe right there. Thanks for watching.